problem number 2 on the same trigonometric ratios, module 5, exercise 6. In this case, we're given a triangle ABC. In the triangle, it is a right angle triangle. We're given the hypotenuse to be 5.6, and there's an angle at C of 67 degrees. Now, the first question, which is A, requests us to calculate the length. The acronym SOR, already gives us the relationship we're looking for. The relationship we're looking for is the relationship between the opposite side and the hypotenuse versus the angle which is angle C, 67 degrees. Now, obviously, we can use the SOR, which is sine. Therefore, sine 67 degrees will be equals to AB, which is the opposite side, over AC, which is the hypotenuse. And this is going to be equals to AB over 5.6. This then tells us that sine 67 degrees is equals to AB over 5.6. Making AB the subject of the formula will then be AB is equals to 5.6 sine 67 degrees. Therefore, AB will then be equals to, then punch it in the calculator, that's going to be 5.6 sine 67 degrees being 5.154, which actually, if you round it off, starting from the fourth digit, that's going to be 5.16 units. So that will be your AB. Let me write AB here as 5.16 because I'm going to wipe off the screen so that we can do B of the same question. Now that we found AB, question B then requests us to find BC. Calculate the length of BC. That's now BC over there. That's BC. And BC is actually adjacent angle C, which is adjacent 67 degrees. So that tells you that if you are given the hypotenuse and you are given this angle and an adjacent side, that means you're going to use a cos function. Be careful not to use the one that you've just calculated, because sometimes you're likely to make mistakes, and then if you use a mistake to calculate a new variable, then you're obviously carrying the mistake into the next portion. So let's not do that. Let's rather we use what we already been given, and then we use that information to get new results. Now for BC, we have already agreed that it's going to be cos 67 degrees is going to be equals to the adjacent side, which is actually BC, over the hypotenuse side, which is AC, and that's going to be BC over AC being 5.6, and then cos 67 degrees is equals to, what's that going to be? That's going to be BC over 5.6. So, in essence, it's telling us that BC will also be equals to 5.6 cos 67 degrees. Therefore, BC is equals to, you punch that into your calculator, 5.6 cos 67 degrees, giving you 2.188. Remember, we're still working on 2 digits after the decimal, so that's going to be 2.19 units. 2.19 units for BC. So that's 2.19 units for BC. Now, having that, now this third question in the same diagram, or in the same the third result we need to look for, that would be them saying, then what is the size of A? The question is, what is the size of A? See, what is the size of angle A? This should be very simple for you. You can use trigonometric ratios. Remember, there are many ways of killing a cat. You can use trigonometric ratios to get this angle, because now you have these sides, which means you can say sine of this angle using the opposite side, which is BC, over the hypotenuse. Or you can use cos of this angle using the opposite side, being now BAB over the what? The hypotenuse. Or thirdly, you can use sum of angles in a triangle. Now, it's going to be much more accurate for you to use sum of angles in a triangle, because remember, if angle C, angle A plus angle B, which already we know is 90 degrees because of this being a right angle triangle, plus angle C, which is given to be 67 degrees, should give me 180 degrees, because it's sum of angles in a triangle that give me 180 degrees. Therefore, angle A plus angle B being 90 degrees plus angle C being 67 degrees will be equals to 180 degrees. Now, angle A plus the sum of these two, which is 90 plus 67, giving you 157 degrees, will be equals to 180 degrees. Therefore, angle A will be equals to 180 degrees minus 157 degrees. And A will then be equals to 23 degrees. That will be your angle A, being 23 degrees. This is one way one could go about it, okay? Now remember, because you've been rounding off these numbers, as much as you can be able to get this angle using your trigonometric ratios, the accuracy will be compromised because of the rounded off figures that you get in AB and BC. However, as a matter of principle, I think let's rather we do it so that you have a view of exactly what I'm talking about. Let's take, for instance, we use the opposite side as AB. So we're going to say a sine 67 degrees. Oh, pardon me for using a red one. I'm going to say sine 67 degrees will be equals to, oh, by the way, we're actually looking for, oh, come on, we're looking for angle A. So sine A will be equals to the opposite side being BC. Sine A will be opposite over hypotenuse, BC over AC, and that's going to be BC, we said it's 2.19 over 5.6. Now sine A is equals to 2.19 over 5.6. Now we're looking for the angle A, therefore the angle A will be equals to the arcsine of 2.19 over 5.6. Therefore angle A will be equals to, then you punch that into your calculator, that's going to be shift, and we got 2.19 over 5.6. That's going to give me 23. Now you see what I was telling you. The calculator gives me 23.0211, and the numbers go on and on. So the percentage of error there caused by the rounded off figure doesn't actually give us the accuracy in terms of it being slightly 23 degrees. Okay, so that's what I've been trying to explain to you in terms of you using the rounded off figures to get the angle. Obviously there's a certain percentage of error that comes with the rounding of your figures. Now let's see if we get nearly the same thing when we're using the adjacent side. So cos A will then be equals to AB over AC, which is actually going to be equals to AB being 5.16 over 5.6, which is my hypotenuse. Now cos A is going to be equals to 5.16 over 5.6, and therefore the angle A will be equals to arc cos of 5.16 over 5.6, and then you punch that into your calculator, then you're going to get cos of 5.16 divided by 5.6, and then that gives you 22. Now you see what I was talking about. That's slightly going to be 23, but actually your calculator gives you 22.86. Now this is basically angle A being slightly equals to 23 degrees. So hence I indicated to you that a percentage of error will always be there, but the most accurate would be for you to use some of the angles in a triangle so that you get accurately equal to 180 degrees. And that's your number 2 of exercise 6 on your module 5. And that's the solutions that you can get. Thank you.